Welcome back to the newest episode of the Duchess and
The Doctor
show with Phil. He's not a German Shepherd. We are answering your questions about eventing, stream processing, Kafka, Flink, and any other related technologies. We got new exciting questions. Anna, you want to kick it off?
Absolutely. Nick from Community Slack asks, can anyone please point me to any example of using Kafka Streams for creating an event-driven system which is connected to an external database?
Ooh, fun one.
It is also very common. This question we get all the time. And while it's not officially embraced and supported, it is really common. Everybody doing it. There are some rules and some things that you need to think about in order to do it successfully. Because we know people are going to do it anyway, right? You might as well equip them to do it properly.
Yeah, we should. There's a very old kib actually. I don't know, maybe 4 years old. So it is kind of lingering around to support external async calls, but nothing happens. So I would say we take kibs, but we already have one. So, but maybe just pick it up.
Yes, I like that. One of the things I want to get out there right away is don't DDoS your external system. The number one thing and the most also heinous thing that people do when they connect an external database and do an external call in Kafka Streams is they DDoS whatever that external system is. Kafka is fast, it can handle a ton of data, and it will take down your system if there's no protection. I've seen it many times. Your DBA is probably doesn't like you anyway, so why give them another reason? Shout out to Glenn, who is DBA, that I worked with. Glenn, hit him up on Twitter. But you don't want to make Glenn mad, so don't DDoS your system. And I just wanted to make sure that anybody, I don't know why anyone would stop listening, but if you were to stop listening, you at least get that point. But there are many, many other considerations too. Considerations about correctness.
Yeah, absolutely. Not just correctness. I mean, there is performance.
Sure.
There's correctness. There's availability. It goes all over the place, right? So yeah, let's go backward. Availability. Kafka Streams has this nice thing that it's totally encapsulated. It only depends on Kafka. So if you say you have an availability thing, well, sure, if Kafka goes down, Kafka Streams goes down, because then, well, if Kafka goes down, you have bigger problems anyway.
Absolutely.
But there's no other external dependencies that you have. Now, if you add the database, you actually get this external dependency. And Kafka Streams is not really designed to pause processing. So if the external database is not available for whatever reason, then the question is, what do you do? I mean, you can bring down your full application, sure, but that's very crude. You usually don't want to do that. And then the question is, what can you do, right? I mean, you can park events and stuff like that inside a state store and stuff like that. But it becomes very gnarly very quickly because you don't even know when the database is coming back online again.
Correct.
So you basically need to design for infinite buffer space and all those kind of things. So in practice, I think the only real option you have to take down the full application and it goes offline.
Yeah. Well, and we actually have patterns, like we call it, like there's an infinite consumer, right? There's a back-off consumer where you wouldn't even use K-streams if this is part of your like fundamental process, because you can actually do a back-off, not commit offsets and just retry infinitely without, at an interval that doesn't DDoS your system. Because it's very common for a lot of these external systems to have weekend maintenance, outages. They're not like Kafka. They can't upgrade in place, right? When it's down, it's down. And so you have to know that going in, that you're hurting your overall availability.
And it's not, I mean, when I said, bring it down, it did not literally mean bring it down. It is just like, well, you can't do it, so you throw an exception. Kafka Streams can catch the exception, actually tickles down, it brings down this thread, but you can restart this thread. Then, of course, with corresponding, retry policies and actually backup policies, right? Because I restart this thread, then if it fails again, right, I double my retry interval, and I wait a certain amount of time until I restart this thread and things like that to basically, avoid like a busy spinning loop. Because if your database is really down for like 2 hours, you don't want to crash the thread, restart it like every 100 milliseconds.
Yes.
That is not helpful.
Well, and I love that. And so we've gone through availability, right? The more systems that are linked together to ensure correct behavior, the greater your chances that one of those systems may fail. I mean, I think that's just, the weakest link.
Yeah, absolutely. Second one, performance. Yeah, I mean, and that boils down a little bit into correctness, because in the end, now we're talking about making synchronous calls versus asynchronous calls. And for performance reason, you obviously want to make asynchronous calls, because synchronous calls are just way too slow.
Correct. They're very blocky.
Yeah, they're very blocky.
Very blocky.
But if you do asynchronous calls, then you get in a completely different bunch of problems.
Indeed. Who's first? Who's second? Who's third?
Yeah. Also, I mean, if you fire off those calls, right, and you fail in between, or they come back in a different order, right?
Yes, the different order is very problematic, yes.
And you also need to do also bookkeeping, right? I mean, Kafka Streams, as we said, does not have built-in mechanisms. So the question, well, if you fire up those callbacks, well, you need to store those handlers somehow in a state store. And you can actually not register like a callback that is executed in an async manner, because in Kafka Streams, you can only do anything in your processing when you're in the process environment, right?
Yep.
So if it comes back and some other code would execute, it would not be in the right context, and then it can fall over as well.
And then when you look at something like Flink, right? Like Apache Flink, they have this asynchronous kind of call out for external
so I have it built in.
Yes, they
for
do.
exactly that reason.
Yep, indeed. So it'd be interesting to see, if that can ever be in any beautiful, semantically correct way be brought to K-Streams. I mean, it's a good question because it does come up a lot.
Yeah, absolutely. No, I mean, we just never got to it.
Yeah.
But it is important. And the bookkeeping is the hard part. And that is the part that the framework or library, whatever, can do for you. All the other things like availability and stuff like that, that's just like an inherent problem that doesn't go away at all, right?
Yes.
If the external system goes down, it goes down and you got a problem.
Now let's talk about my favorite one. Correctness, because I love it. My favorite is, and I always tell people this, the first question I ask them is, I say, are you just kind of pulling something back to enrich? Because if they say yes, then I'm like, okay. But sometimes people will look at me and they'll go, no, we're just inserting this. And I'm like, have you heard of the retry policy in Apache Kafka? Because what can happen, and I've seen this happen multiple times, Kafka will retry, right? The default semantics is at least once, which means more than once. So if it gets stuck or it keeps trying and it keeps trying to do something and there's a problem, it could retry once, could retry 10 times, it could retry 100 million times. So if you're doing something that's not idempotent, beware, because you don't have a guarantee that things are going to happen however many times with your external system. Kafka's guarantees of whether it's at least once, whether it's exactly once, they don't exist outside of Kafka and Kafka Streams when you throw an external system in there. Yeah,
absolutely. I think especially the exactly once point is very, very important. And I mean, there's a lot of talks about exactly once, and the most important thing is really, if you do exactly once with Kafka, it does not mean there's no retries. There's retries all over the place. It's just like semantically, those retries are automatically hidden, so it doesn't affect downstream systems, but there are retries. But those external system calls are not covered by this, we hide the side effect of the retry. So for them, basically EOS breaks, and you are in a tricky position.
This is correct.
So now the question is, of course, what are the alternatives to doing external system calls to begin with?
You know my favorite one.
Which one?
CDC.
Oh yeah, that's a very good alternative. That depends a little bit on the use case you're doing, obviously.
True.
But if you say, I do lookups into an external database, then the recommended pattern is actually to avoid that. Use CDC to copy the data into a topic in Kafka, and then you load it into a KTable. And then instead of doing external system calls, you just do join. That is a built-in operator, and then you're fine. So now, of course, the external system could still go down, but now the side effect is only that your data gets stale.
Right.
But Kafka Streams doesn't crash because, it doesn't get the updates. But very often, the updates to the external database are not so frequent anyway. Again, depending on the use case and all those kind of things. But, the damage done is basically much more limited.
Well, and if the system is down, nobody's updating it.
That's true.
So you're a little bit covered there,
yeah,
right?
That's true.
Yes, yeah, absolutely.
Yeah. The other advantage, because we talked about correctness, if you do that, is actually if you use the latest and greatest in Kafka Streams, versioned KTables, you get actually much better semantics. Because external databases, well, they usually have one value per primary key, but they do not have a history.
No.
But when we load the data into a version KTable, we can actually bookkeep the history.
Yes. And sometimes, this is one of the things I love the most. Sometimes you really do want to align because there's all these systems sending events. Sometimes you really want to align or enrich with what something looked like at the time the event happened.
Exactly.
Right? So if I want to know if somebody tries to do something with their account, they change their name, their address, or whatever it is, right? I need to know what it looked like when they actually made that change. not maybe what it looks like in the latest. So if I can back that in, that's hugely valuable for use cases.
Yeah, absolutely. Another good example is pricing and changes. I buy something at a certain point in time, and the price changes later, but my event comes in out of order. I don't want to pay the higher price because it was increased, because I clicked when the price was happening, right?
Correct.
So if you do those bookkeeping and stuff like that, for correctness reasons, you want to have the version history.
Yes.
And that's luckily all built in Kafka Streams now. Not enabled by default yet, but that's coming.
So that's very, very cool.
Other problem, what can you do if you have a REST APIs that you're hitting on an external database?
Yeah, that is a problem.
That's all you got?
I always say like that is when if you don't have control and you can't address the source of truth via C2C or something like that and load it up. Everything solution I've seen where like I'm just going to hit it for every key and then just refresh, and that's vomitous. That's not cool, and I don't like it. And so at that point, one, if all you're doing is pulling back information and it can handle the volume, I don't have a problem putting that in K-Streams. Because it's easy, it's simple, as long as you're, covering all your bases. And two, the other option I think was use a custom consumer, right? And you can send events. So you actually could send an event, event drive it. Now, do we wish there was a more direct and simple pattern? Yeah, perhaps, right? But it is what it is. And so what you could do is you could say, hey, right, I need some information about this key. You send an event, right? This key came in. That service consumes the key came in or whatever, right? And then it does its work in the REST API by itself, looks it up, sends it back in the event loop, and you pick it up.
Yeah, splitting it out is a very good thing. And I mean, Kafka Streams or other frameworks already having this ability to split up complex problems into subgraphs and whatever, and then you just, split it into multiple jobs, take this very tiny piece out into a custom application, connect it with topics, and then you're done.
Yeah, and I would say, that's really also common when integrating with third systems, like when I need to drop something off on like one old crusty queue or something like that, and I need to get that back because that's our old third-party system, right? Using eventing to do that, separating that out from your main processing, I think is very valuable. Allows you to detect what if I never get the event back from that primary system without actually hosing up stuff, right? Yeah. You can actually work as things come in.
Yeah. I think that is the best solution for this pattern. So I think we have answered that question.
Yes. Fun times. On to the next?
Yep.
All right. This question comes in from YouTube. Does Kafka provide a snapshot capability? So if I have an event stream that has hundreds or thousands of updates, I can periodically snapshot the state and reduce the computation required to determine the current state by processing fewer chronological events.
Ooh, that's interesting.
It is.
Did you notice the error in the question?
I did, and I was waiting for you to bring it up because it's Matthias, and I figured that you would, right? So my favorite thing, we talked about this before, is immutability. So technically, right, and this is again technically, I think the spirit of the question is different, but in order not to confuse anyone, if there's an event stream, it never has hundreds or thousands of updates.
Exactly.
It's probably not what the person meant, but just to clarify, right? Immutability is your friend. Change is the enemy. Okay, didn't I say that earlier too?
Yeah, I mean, we started with that.
Yes. And so let's talk about the heart of this question. The question is, how annoying is it when I have to read from the beginning of a Kafka topic in all time and compute state every time I need it? Very annoying.
Yeah, absolutely. I mean, the first thing that comes to mind is obviously compacted topics. Mm-hmm. Very old technique. So for new listeners, the difference of a topic with retention time, what is the standard, where you basically say, I keep data for 7 days, everything is always throw away, is a compacted topic, where you basically say, I have those key-value pairs in Kafka, and it treats a key as a primary key. And so for every key-value pair, now I want to keep the latest key-value pair, and all older ones can now be discarded.
Right.
And that is called compaction.
It is, and let's make an important point here. It's eventually compacted. Kafka is not a key-value store. So eventually, only the latest data for a given key will be there. So you really can't use it. You've got to embrace duplicates. There may be duplicates in keys because older entries may not have been compacted away yet. And that's a common issue you have where people say, like, what the heck? Because compaction happens at an interval outside of your control on the brokers. So while that is absolutely a solution, you should know that actual implementation detail as well.
I think the other part is also, this works if you really start up the application like fresh, and you say, I go back to the very beginning of the topic. Now I can read, hopefully, already fully compacted snapshot. Most likely not, but hopefully.
Yeah.
But then, of course, the application keeps running. And now you get all the updates in, right? And you're reading from the tail of the topic. So basically, well, you don't get any compaction because compaction is always lagging behind.
Correct. So you're still reading every single event.
Exactly.
That's right. It's like a one-time benefit.
Yeah, it's a one-time benefit.
Yep.
Yeah. But now, of course, when we talk about like deduplicating those things, now Kafka Streams comes into place and it can help. And our good old suppress operators that we talked before. So if you read the data into a KTable, then we upsert it into a RocksDB and we do an implicit deduplication. So now again, by default, every update to RocksDB says, well, I stream it downstream because I got an update. Everything is event-driven, how it should be.
Yes.
But for this case, you would say, well, I actually don't want to have every intermediate result, right?
Correct.
So now we have those KTable caches already that are built in. And if you want to have more control over it, then you can use suppress.
Yep.
To basically say, I control fine-grained how many of those events I actually want to send downstream. This can be time-based or update-based. I forgot what policies we have on top of my head. But you're very flexible here. And if you even need more flexibility, then you can always drop down and build a custom processor. So it's not hard to write. Just take in the data, you put into key-value store, and then build your own business logic when you actually say, okay, this event is worth forwarding for further processing.
Yeah, and I think what we're talking about is there's initial hydration. And that's usually what we call, how do I hydrate this, right? And initial hydration can be done with a compacted topic, right? With the disclaimers that we've talked about. And then when we talk about how do I send a full state of the world view, right? And it's much more controllable via several buttons and knobbies if you want to use Kafka Streams, KTables, a combination of suppress, all of these wonderful items. And I also think it makes sense too to talk about global KTables here. Because it's one thing, and every time I see someone try to reinvent Kafka Streams, they're like, well, no, I'm using static partitioning because I have this in the, just sitting in like memory in the Java app, and I need it to be partition-based because there's no way for me to have a full state of the world in every single instance. Well, there is in Kafka Streams, and that's a global KTable. So you can actually populate every instance of your application with the data from every single partition in a topic. And that comes in very handy.
Yeah, sure. If the data is small enough, obviously, because that's a broadcast pattern. So it's expensive.
Yeah. Well, and also, data you have to pay the price somewhere.
Yeah.
Right.
Yeah, that's true.
But global KTables are very, very popular for this exact reason. And I think, there have been actually a lot of requests to have global KTables implemented, that idea implemented in a lot of other libraries. Like, they're like, well, I want this for Kafka.js. Or why doesn't Liberty Kafka have this? I want it for .NET, right? And I think the issue that you have when you don't have it is you find people who are creating these event topics with a single partition.
Yeah, that doesn't scale.
No, it doesn't. But there's no other way for them if they're outside of Kafka Streams and outside of Java, right? Which is, if you're a .NET shop or then, you've got to figure out a way to do it. And it forces people into that kind of conundrum where, well, I don't have a global KTable or some sort of entity that acts like that available to me. So the only way that I can make sure that every single instance of this application receives this is a single partition.
Makes sense.
Yeah. So it would be great to have more of those. We should open up some more. Is it KIPs? No. Now, what would we open those? Maybe just pull requests. Shout out to Magnus. I miss you, buddy. It's Liberty Kafka.
It rules.
It does.
I mean, to wrap it up, basically, I think the answer is there's not really like a snapshot in Kafka or Kafka Streams.
Right.
So that doesn't really exist. But if you do eventing, you also don't want snapshots. That's way too batchy.
Yes.
But there are also mechanisms to basically reduce the load, and that it's also the other core of the question, right? I'm not sure if the question is really about the snapshot itself or about the ability to basically boil down the number of messages or updates you're processing. To not DDoS the downstream system or something like that.
And to quickly hydrate state.
Yeah,
right?
and to quickly hydrate state. And so basically the basic building blocks are there. It's not strict snapshotting, but yeah, you don't want that anyway.
I love this. Well, all right. I think this wraps up our third episode of the Duchess
And the Doctor.
show. And thank you for being with us today.